Okay, I'm not going to keep you long. I'm not even going to probably go through my entire lecture because I think there's other things to do, but I do want to point out a couple key things. If we go back and look at the course objectives, they're about developing skills, communication, thinking, responsibility. We didn't touch on the last one as much as the other two, but I would have to say that after we had some calibration glitches at the beginning of the course, you folks responded well, and I think we've satisfied what I hope for the skills and content requirement. You also, if you've been adding up points, you remember back from the syllabus, there's 800 possible points. And there's a screwy scaling scheme for it. But we've already offered 813, so that means we actually don't have to offer any more. It's based on 800. So where does that leave us? We've accomplished the goals. We've got all the points we're going to get. I wasn't planning on having any class next week, and this one's going to be abridged. So this is it. Anybody object? Okay. I'm not going to go into, this is called my doom and gloom lecture. I'm not going to go into the whole song and dance, but let's spend a few minutes thinking about climate sensitivity, an analytical way to get at what is supposed to be a metric of CO2 and temperature change. We discovered its flaws, that it's not a single number. We talked about droughts and deluges, that's changing the atmosphere circulation patterns, the ocean circulation patterns, and the AMOC disruption. And then, at least in the geologic record, ecological reorganizations, particularly the Younger Dryas and some other events. We talked about sea level, because the sea level that's coming up in the short term, sort of the next couple centuries, is going to be significant economically and culturally, but is minor compared to what's happened in the past. The ice sheet instability hypothesis has to do with whether that sea level rise could be fast or slow. I don't have enough information to personally get to one way or the other on that. I'm in favor of the geologic record. That's if the ice sheet is more stable than when we're advertised. The CO2, we're going to talk about carbon capturing. We're opposing companies to get more moving about doing things for carbon capturing. Some companies are going to carbon capture CO2 in order to pump more fossil fuels. But the reality is that we've changed the chemistry of the atmosphere in the last 100 years, and it's not going to change back anytime soon, regardless of how fast we do it. And then my favorite, ending with abrupt climate change, because you put all this together, it happens fast. And rhetorically, we could ask if these lessons could guide the future. Some of them do. Some of those messages, I think we spent more time worrying about what the message was rather than what are the lessons exactly we could learn and what to do with that information. I'm not an advanced planner. I study the past, and I've tried to put some relevance into the past. And there are key take-home points from the past, and I'm concerned because of the lessons that I've learned from the past, and I'm just going to articulate a personal perspective for the rest of this term. The reality is, their switch, the so-called climate switch, it's, in my opinion, going to happen faster than most people are anticipating. It's going to be sudden, it's going to be high, it's going to be irreversible. It's not going to be a degree or two in the next century. That was the question I asked on this week's assignment, and quite a few of you were in agreement with that. I've spent over 4 decades wandering around on glaciers, looking at glaciers back in the late 70s, so I go into Antarctica and subsequent trips to the southern hemisphere. This is my work, this is my real work clothes, not these clothes I have on. And I've been able to reflect on this business of how glaciers and climate interact. This is a small ice cap, one of my favorite in East Greenland. the little ice age is there, the present day glacier is there, the flat plateau means that it's going to be gone in probably 50, 75 years. There's no place for the snow to pile up. The one thing that on all time scales that I've looked at, and I've looked at time scales, these are all different time scales, they're all the same way. This is the little ice age, the warming, so I've looked at centuries. I've looked at things that occur over tens of thousands or thousands of years. There's an oscillation pattern in here, and I'm concerned with these terminations. All those patterns look exactly the same. I never understood that. But the conclusion you draw is that somehow the climate system keeps crossing some sort of threshold, and it happens on different time scales that I can see. You could do meteorological ones too. Back in '97, a guy named Wally Broker said, will our ride into the greenhouse future be a smooth one? He was basically asking whether we would be able to predict it and culturally respond to it. This is the Southern Alps of New Zealand. Here's something called the Waiho Loop. It's the former position of that glacier system. It was, at that time, was thought to be the Younger Dryas event. It's been reconsidered in that model now. But the point is that Wally was an eminent paleoclimatologist, and he studied the ocean for most of his career. But then he got worried about the whole behavior of the system with the feedback loops. And so he was a big advocate of a specific cause for the Younger Dryas. But that made him worry about it because he was saying, well, look, there's something called, you know, we've got this climate in two different lockstep somehow, and it has several modes of operation. So this was the recognition back 26 years ago that there's a suddenness to the thing. So he was asking about whether it was going to be smooth or bumpy. Obviously, if it's sudden, then it would be bumpy. And the type section of that is the Younger Dryas, which we studied in the past. And so the Little Ice Age is sometimes considered one of these events, but it's not. The so-called 8.2 event that we looked at generally is supposed to be. So the abrupt changes happen at all time scales as far as I can see, and that might be a prejudice. But back to the Younger Dryas, Wally had an idea because he was an oceanographer, so he developed this thermal haline circulation pattern. The notion that that the ocean has to behave to density-driven features and transport energy. And this schematic diagram's all over the place, and it's basically right. The question, though, became, how do you disrupt this? This is the same, we talked about this in the AMOC circulation, but the leading way to whack it is to throw a bunch of cold water in it. And back in the 90s, the cold water was thought to be something called Glacial Lake Agassiz, basically here, that suddenly flooded and came out this way, out through the Gulf of St. Lawrence, and upset this balance. And this was the prevailing paradigm. It was in textbooks, and everybody was happy. Zooming in on an area, this would be something of, this is misleading, but this is a sort of a geometry of this lake. And then the argument would be that it all of a sudden catastrophically released through here, went out here into the ocean and did that. So I got involved with, because that at that point was the only physical mechanism for abrupt climate change. The only thing that explained the Younger Dryas. Along with Wally, under Wally's, began to get the explanation. I spent about 10 years thrashing around in this part of Ontario trying to find out if that flood actually happened or not. And this is Wally Broker, a fellow named George Denton, who I've been working with for years. He's the Zealander switch paper. And this guy, Jim Teller, who's advocating the catastrophic release of Agassiz. The fellow you won't recognize, you may or may not know his name, is Gary Comer. He founded a little company called Land's End. When I met him, he was retired from Land's End. He had sold it to Sears. And he had taken his boat, little boat, the Turmoil, around the Northwest Passage. And he was smart enough to recognize that why can I take this tourist boat around the Northwest Passage when 100 years ago people couldn't get through there? And that got him thinking about climate change. And then he approached a broker, and then Denton, and then myself. And then Mr. Comer eventually outfitted the Turmoil, that's called the Turmoil, with a helicopter so that we could do some work in Greenland. So he was committed to this business of trying to sort out the climate change. So again, we were worried about the Younger Dryas. Like I said, I couldn't find any evidence of the flood. So that pulls the mechanism, the only mechanism we had. And so if that's not good, then what does that mean? We still need to explain the abrupt climate change. There are now alternate mechanisms, but it leaves us sort of after, sort of through the span of my career, of not having a plausible mechanism to explain how this abruptness happens. And that's kind of not satisfying, because we know climate happens, it flips, and it's as fast as we can measure it. So that's telling us that our understanding of it's incomplete. So I've been worried about the CO2 gases, as everybody has, and it's a compressed time scale, but there's a change, and you see the things about how many millions of years ago or whatever. We're right about here. We're going to elevate up into here, which takes us back through the age of the ice sheets to CO2 levels. Whether it'll get that warm, nobody has a clue. Richard Alley once showed me this graph, and what he does is he runs out the probability of things. And if it's a problem that you're worried about, there's a probability of some sort of solution. And for the climate system, there's little probability that with greenhouse forcing that the climate change will be slower or smaller than we think. There's some, not zero, chance that it'll be bigger than we think. And because the IPCC, which is the governing body, is interested in consensus, they pick a middle of the road estimate. If you look at that curve, it's the same for the probability of the climate sensitivity. So this climate sensitivity, though, has a tail that's out here. I'm willing to bet any number of adult beverages at this point that the reality is going to be out on the tail. That's my conclusion after studying this for 40 years. So if we don't understand him any better than we did 26 years ago when he was concerned, yet we're throwing CO2 in the atmosphere, I think that's going to put us out on the tail of problems. I've spent my career trying to figure out how climate works, and I'm about ready to close that career down, and I've never come around to what to do about it. That's the challenge for you folks. How are you going to respond to it? How are you going to deal with it? It's going to happen. It's going to happen. You can debate about the rate, but it's going to happen. The switch hypothesis could make it hairier, and that'll put us in all kinds of challenges. And how much time to respond? The homework exercise I asked you, this was going on today. That's already underway. I don't know if that's going to pan out to be. It could be a little blip that's really warm for a couple of years and back, and then another blip, and then it goes nuts. Doesn't matter. We won't know it's coming until after it happens. So we won't ever be able to prepare for it without starting yesterday. Personally, I've spent 4 decades looking at this stuff. I'm down to the mode flips as being the best way to tie together the system and the inherent instability of it. And really the question isn't how the climate works. It doesn't matter. How do you live with it? Personally, I have my future to the world is going to be worrying about some personal properties that I acquired from my parents. Basically, I have 100 acres of woodlot that I'm going to leave basically unchanged. That's the only contribution I can make. 100 acres isn't going to make a difference one way or the other. I've never had children by choice, and that's probably the biggest reduction of CO2 that I can do. I'm pretty sure my generation of scientists is going to get blamed by probably your offspring, if not by you folks, for not warning them of the climate change. We've tried, we haven't succeeded. We're not doing much. We're doing far more now than we were when I started teaching this course. We're not doing enough, but you know, I'm just wondering if that the blame will be back on you people. Why didn't you people tell us more? And if the climate really goes downhill, there'll be some blame all the way around. Broker likes to, in one of his textbooks, has us with a big stick pointing it at the angry beast of climate, his neck, and he keeps thinking that we keep prodding it. And he wonders if that's a good idea. Of course, the reality is that if things really go further south, the lesson of what are the three things a species can do. You can figure out how to move, which really doesn't work nowadays unless everyone wants to go to Canada, and that won't happen. You can figure out how to adapt, or you can die. Society's choice is yours. I don't know. I can't advise you on where it is to do it, which will happen. If the ride's not going to be smooth, it's not going to be linear. And one of those strategies is more likely with the abrupt climate change. I'm about done talking. And I'd wish you a good rest of your lives, and I hope that you figure out how to adapt to it. Have a good Thanksgiving. Thanks for coming today. And you don't have to plan on coming again. Okay.
Thank you.
You're welcome.